All right, SPSS fans, the big dog, regression. It's pretty awesome. It's the hardest thing we're going to learn in this class, but it's not particularly hard. Let me start out by saying that psychology as a field, actually any of the behavioral sciences, we really suck at predicting behavior. Let's be very honest, right? We're just bad because human behavior is so unpredictable. But that gets me to this point that regression can be so valuable because it is a predictive technique. How to let me clear my Instagram there. Sorry. How to predict human behavior with some degree of accuracy. So we're working with our old friend car data. If you go to analyze, we'll start there. Regression is down here about halfway, right? And don't do automatic, do linear. Okay. And what we're trying to do here is basically predict y by knowing x or x's, right? So in this case, I might ask you a question of how well do horsepower, engine size, and curb weight predict price, right? So let's do price in thousands. Our y value will always go at the top, our y variable. We've got engine size, horsepower, and curb weight. Those are the three I mentioned in my question. We will not mess with these boxes at all in this course, so just kind of keep that in mind. We'll use y and we'll use x, okay? And you don't have to click on any of these bad boys over here, right? Very simple, this and this, but make sure you put them in the right place. What we're predicting goes up here, and what we're trying to predict with goes right here, okay? We hit OK. For some reason, it just took me back to the data. There we are, all right, here we go. So let me minimize. So we've got our ANOVA here. What I want to point out, the important thing from regression is our capital R value. This capital R, as it says in your textbook, represents the multiple correlation coefficient. So remember, lowercase r is the correlation coefficient that we used a few units ago in correlation. Capital R is the multiple correlation coefficient that you can associate with regression. And I think it's straightforward. Capital R regression. I don't know, it fits. In this case, what we're seeing is a 0.859. In regression, that R value can only ever reach 1. And if you ever get an R value of 1, you better patent or copyright the equation you just ran because it's worth some good money. Because we just don't predict at that level. It just doesn't happen. Okay? So 0.859 is darn good. I would say anything above about 0.75 is good, but 0.859 is pretty impressive. And a lot of corporations use regression modeling, actually almost all, in fact. So we're using car data here. Big companies like Chevrolet and Ford and Toyota, these companies actually all use regression modeling to decide how much to charge for a car, how many cars they're going to sell, what their financial projections will be, blah, 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 blah. But basically, they're always trying to refine this. The higher this is, the more accurate it is, and the more money you stand to gain or lose depending on where this R value goes. Okay, so here's our R value. What I want to draw your attention to next too is down here, right? So we've got engine size, horsepower, and curb weight. All of these are the variables that we entered as predictive variables. And what this significance column, keep in mind significance, 0.05, what the significance column at the end tells us is how significant those predictors are. So basically how much they contribute to the equation and whether or not they significantly contribute to the equation, right? So in this case, engine size does, horsepower does, and curb weight does as well, right? Let me show you if we ran the equation again, but we added a new variable. Let's say we're trying to, wrong data set. There we go. Let's say we're trying to make this even more predictively valid. We're trying to get above 0.859. So I go once again here. SPSS loves me, so at least what I had in there already. And let's throw something in there like, let's do length. Let's see what length does for all of this. So I throw it in there for as an X variable. So we've got 4 predictors now, same predicted variable, and I hit OK. Okay. So I come now down to my new model. Notice my R value went up, 0.883, right? Which is good. That's what we wanted. If I come down here, what I notice is length is also a significant predictor, right? All of them. Notice these significant levels have changed because my equation is new. So length is a significant predictor. I want to hang on to that. That's very important. So my equation is getting better. This is the purpose of regression, is to run equation after equation and improve that R value. So let me think, let's say I'm getting really confident, kind of full of myself, and I'm like, okay, I've got these already. Those are good. Let's try fuel capacity. Okay, let's see what that looks like. I throw it in there. I've got 5 predictors now, still 1 prediction or predicted variable. Notice my R value does not change. 0.883, the exact thing it was above, right? If I scroll down, right, see how my significance is there? 1 has changed. These are all still significant though, but when I look at fuel capacity, Notice fuel capacity has a significance of 0.882, which means it is a non-significant predictor. In this case, if I was to run the equation again, I would take fuel capacity out. It is not significantly predicting what we need it to. So I would choose a different variable to utilize in its place. This is the essence of regression, reiterative equations, trying to get that predictive value up closer and closer to 1.